Back to Biomed Buddy. This is a training film on the STA Compact manufactured by Diagnostica Stago. Today we are going to go over the access controls of this instrument. This is the movements of arm number 1, which houses needles number 1, 2, and 3, which are used for transporting of samples and reagents, and arm number 2, which is responsible for picking up the cuvettes and delivering them to the incubation and measurement wells. As you see from the block diagram here, most of the signals come from the 4-port serial board, which we covered earlier in this training session. The direct signals that come from the 4-port serial board go to the DC motor board and the 4-axis board. Onto the DC motor board and the 4-axis board. In general, the access control consists of one 4-axis board, which control the X, Y movements of arms 1 and 2. Arm 1 contains the pipetting head. Arm 2 contains the suction head for transporting of the cuvettes from the shuttle to the measurement block. One DC motor driver board, which controls the Z motors, meaning the up and down of needles 1, 2, 3, and it controls the Z movement of arm 2, up and down. 4 stepper motors, 5 zero-axis boards, 1 multifunction pipetting head board, which is located on the pipetting head, 1 heating pipetting head board, which is again located on the pipetting head, 1 connection pipetting head board, again located on the pipetting head, 4 stepper motors, X, Y, and pipetter, 4 direct current motors, Z movements, needle 1, needle 2, needle 3, and the cuvette, arm 2 motor. The pipetting head is equipped with the 3 needles. The movements for the X and the Y are completed by means of belts and a return pulley. The suction head, which I'm referring to as arm 2, movement is made by a Y belt and a return pulley. All of the Z movements, the up and down, are controlled by the DC motor control board. The general purpose of the section is to pipette and dispense samples and reagents to the cuvettes and to move those cuvettes from the shuttle to the incubation, from the incubation to the measurement wells. It also controls the movement of the pipetter, which is referred to in general as P1. This movement controlled by 2 boards. 4-axis board for the stepper motors, X, Y, and P, and a DC motor driver board for all Z movements. All of these movements are synchronized between the DC motor driver board and the 4-axis board. Let's take one board at a time. Let's start with the 4-axis board. Again, the power supplies for that are the plus 5 volts, plus 12 volts, and to 28 volts AC. On this board there are 6 LEDs. The first 4 are for axis movements, Y1, X1, P1, and Y2 axis. The green one, which is D11, means the 40 volts power supply is okay, and the other green one, which is D5, and it basically states there is power going to that board. The 4-axis board controls the Y movement for the suction head, arm 2, the movement of the pipetter, which is the P1, going up and down, the X movement of the pipetting head, the Y movement of the pipetting head. Again, the pipetting head is arm 1, which has the 3 needles. The voltage, 40 volts, is generated from the 28 volts AC supplied to the 4-axis board. Many signals are generated to this board from the input-output board. I will also tell you the 4-axis board generates a local 5 volts from that 28 volt power supply. 4-axis board. In general, when you see it go bad, the motor just doesn't turn. One of the common problems with that would be blown fuses. And in reference to blown fuses, the easiest way to troubleshoot blown fuses is to pull out pretty much all the boards and stick them into the instrument one at a time to include the additional component board. I believe we will troubleshoot that, go through that scenario later in some of the troubleshooting. Welcome back to Biomed Buddy. This is a training film on the STA Compact manufacturer.